We're talking about multiplying binomials today, and binomials are something in the form of like x plus 3 or 2x minus 1. We're just multiplying those two together, okay? But first, to get there, I want you to think about how you would multiply 15 by 12. A lot of you guys would think, well, the first way a lot of people think is, well, I just stack them on top of each other, and I multiply. I get 10 and 3, and then 0, and then 1 and 5 is 5, and 1 and 1 is 1, and I get 180. So that's one way some people do it. Some people multiply it maybe with something called the lattice method. I don't know this method very well, so I will just kind of give you a quick rundown. That's 1 and 5 and 1 and 2. And then you multiply that, and that becomes 10, 5, 1, and 2. And then you add them together, and when you add them together, you get 180 as well. One person in one of the classes said that she multiplies 10 by 15 and then adds that to 2 times 15. So basically she says 10 plus 2 times 15. That's another method. So let's think about how we could model this with base 10 blocks, or with algebra tiles. Not base 10 blocks, we have algebra tiles. So I'll show you my model here. So this green one is 10. And the algebra tiles we have in class are a little bit more obvious because they have 10 little boxes on them. So if I wanted to multiply 10 by 12, it's the same as doing 10 groups, or 10 by 12, 15 by 12. It's the same as doing 15 groups of 12 or 12 groups of 15. So here I have a group of 15, and I want to do 12 groups of 15. So to do that, really I have, here's one group of 15, right? Because this is 10, and then that's all those ones. And then there's another group of 15. And inside of this, I end up with 10 groups of 15. And then I need 2 more groups, so I have this group and this group to give me 2 more groups of 15. So if you look at this and you see, what did we do here? How did we figure out what we had? Oh, that was not the right one. Okay, there we go. That's better. So what do we actually have here? Well, we end up with kind of like 10 times 10, 5 times 10, 2 times 10, and 5 times 2, right? This is 10 groups of 10, 10 groups of 1, or 5 groups of 10, 2 groups of 10, and 5 groups of 1, 2. You know what I mean. Okay. So basically, if we did this, if we drew a little box here, we could see we kind of have 4 quadrants. We did 10 times 10, which is 100. Then we did 10 times 5, which is 50. And then 10 times 2, which is 20. And then 5 times 2, which is 10. And if I add all those together, sure enough, I get 180. And actually, if you know anything about that method where we stack on top of each other, really, that's all we're doing. 15 times 12. When we stack, all we do is we say, okay, 2 times 5 is 10. And we just take our 1 up there so that we can add it to the next one. And then we do 2 times 10, which is 20, and then we add the 10 from before, which is 30. And then we do 10 times 5, which is 50. See, that's where that 0 comes from. And then 1 times 1 is 100, and so I put that there, and that's where I get the 180. So really, that's exactly what I did. I'm just breaking it apart into different pieces, but in this method, I see it a little bit differently in a box. So what if I wanted to do that for 22 times 24? If I wanted to 20 plus 2 times 20 plus 4. Could I just multiply each of these parts by each other part, and I would end up with the same, right? If I did 24 groups of 22, I would just stack them. And I would end up with 20 groups of 20, 2 groups of 20, 20 groups of 4, and 2 groups of 4. So I could just multiply. Well, what's 20 groups of 20? That would be 400. 20 groups of 2 is 40. 20 groups of 4 is 80. And 4 groups of 2 is 8. So if I add all these together, I get 528 for 22 times 24. Now what if that was x plus 2 and x plus 4? Shouldn't I be able to multiply it the same way? So if I had x plus 2 and x plus 4, if I split this apart, instead of a 20 here, now I just have an x. Shouldn't I just still be able to multiply those two together? I have x groups of x. Well, x groups of x is x times x, which is x squared. And then 2 groups of x is just 2x. And then 4 groups of x is just 4x. And 4 groups of 2 is 8. So I multiply all those together, and I notice that these two are similar terms, so I can add them together. So now I have x squared plus 6x plus 8. And if you learned something called FOIL, you know that this is exactly what you would have gotten with FOIL. Basically, it's just distributive property. So if you think about it, when I multiply these, I have to multiply this 2 by the x, and I have to multiply the 2 by the 4. I have to multiply this x by the x, and I have to multiply it by the 4. If you remember FOIL, it's like first, outside, inside, last. There's a little FOIL man for you. So our FOIL man there, we just do first, outside, inside, last. It's the same process, right? This is the first term. Here is the outside term, x times 4. Here's the inside term, and here's the last term. What I love about this is it's just easier and it's more compact. It's easier to see, and it helps you when you're multiplying polynomials, when you have more than just x plus 2. It's much easier to multiply them in this manner than it is just by taking term by term. So let's practice what this looks like with the box method. So we can call this the area model or the box method. We're going to use this for a lot of stuff. We use it for multiplying, we use it for factoring, we use it for dividing polynomials. It's super useful. And I understand that's a little different than FOIL, but I think when you use it enough, you're actually going to love it. So I have 2x plus 1 and x plus 7. I put them like this because that helps me multiply this by x and this by 7. Then it helps me multiply x by 1. You know, it helps me multiply everything by each term that I'm supposed to multiply it by. So when I have 2x times x, that would be 2x squared. 1 times x is x. 7 times 2x is 14x. And 7 times 1 is 7. Now, I notice that I have some similar terms, so I just go ahead and put them together. So I have 2x squared plus 15x plus 7. And these two are the same expression. What I want you to understand is when I multiply it from here to here, these are the same thing, just in different clothing, right? This is this expression, and this is the same expression, just written differently. They are not different expressions. They are the exact same, just written in a different form. So let's look at this one. This is something, I will say it over and over and over. I need to make a big old poster for my room. Functions do not distribute. This here, squared, is a function. It does something to our numbers. It's not just like multiplying or dividing, adding, and subtracting. It's a function. Functions do not distribute. So this 2 absolutely does not just distribute to the x and distribute to the 9. You do not just get x squared plus 9. That is not what this is, because functions do not distribute. What this really means is x plus 3 times x plus 3. Now we can use FOIL or the box method to see how to multiply those two together. Remember, we need to multiply the first x by everything on the other one, and then we need to multiply every term by every term. This x has to multiply by the x and the 3, and this 3 has to multiply by this x and the 3. Okay, so that's why I love the boxes, because it helps keep it organized. So I can put x squared, 3x, and 9. So I end up with x squared plus 6x plus 9. Do you see how that's different than just x squared plus 9? Yes, we don't want to do that. So once again, functions do not distribute. So we just multiply x plus 3 times x plus 3. All right, this is our last one. If I want to use the box method for this one, I would say 5x minus 1 and 6x plus 5. That would be 30x squared minus 6x plus 25x minus 5. So that would be 30x squared plus 19x minus 5. And again, these two are equivalent expressions. They are the same thing. All I did is I just changed the form from here to here. And guess what? With factoring, which I'll do a video on next, you can go from here to here.